Hello everyone, welcome to our art integration project on topic nephron structure and its function. This is Debabrat sahu of standard 10D in Guru Nanak Public School and he is my co-partner
Akash swain. Nephron structure and its function. Nephron, functional and structural unit of the kidney. Approximately 1 million nephrons per kidney. Each nephron has two components, vascular component and tubular component. Nephron's tubular component, efferent arteriole, glomerulus, renal corpuscle, which is further divided into three parts, proximal convoluted tubule, loop of Henle, distal convoluted tubule, which are followed by a collecting system, that is collecting duct and a papillary duct. Bowman's capsule, expanded double-walled invagination that cups around the glomerulus to collect fluid from the glomerular capillaries. From Bowman's capsule, filtered fluid passes into PCT. PCT lies entirely in the cortex. From PCT, fluid passes into loop of Henle. Loop of Henle, from U-shaped or hairpin loop. It dips into renal medulla. Descending limb of loop of Henle goes from cortex to medulla, and ascending limb of loop of Henle passes from medulla to cortex. Ascending limb of loop of Henle forms distal convoluted tubule. It lies in cortex.
nephron, its vascular component. Dominant part is the glomerulus. Glomerulus is a tuft of glomerular capillaries. Large amount of fluid and solutes are filtered from the blood. The series of blood vessels in the kidney are renal artery, efferent arteriole, glomerulus, efferent arteriole, capillary network supplying nephron, and renal vein. Vascular component. Renal artery enters to the kidney and forms efferent arteriole, which supplies each nephron. Efferent arteriole delivers blood to the glomerulus. Glomerular capillary rejoin to form another arteriole, the efferent arteriole. The blood that was not filtered in the glomerulus goes to efferent arteriole. Efferent arteriole gives second set of capillaries, the peritubular capillary, which supply the renal tissue and are important in exchange with tubular system. Peritubular capillary rejoin to form venules that drain in renal vein. Nephron. There are two types of nephrons, distinguished by location and length of their structure, juxtamedullary nephron and cortical nephron. Urine formation, basic renal process, glomerular filtration, tubular reabsorption and tubular secretion. Urine results from these three processes. The equation for urine formation is excretion is equal to filtration subtracted by reabsorption added by secretion. Important. All nephron originate in the cortex. Glomeruli of cortical nephron lie in the outer layer of cortex and glomeruli of juxtamedullary nephron lie in the inner layer of the cortex near the medulla. The kidney cannot regenerate new nephron. Aging causes a gradual decrease in nephron number.
So let us come across some of the methods to filter the blood apart from the natural process of ultrafiltration. This process is called hemodialysis. Medical procedure to remove fluid and waste products from blood and to correct electrolyte imbalance, done using a dialysis machine and dialyzer, also called as artificial kidney. Principle of hemodialysis. Diffusion, passive movement of solute across a semipermeable membrane. Ultrafiltration, solute plus fluid removal across semipermeable membrane down a pressure gradient. Hemodialysis apparatus, dialyzer, dialysate, blood delivery system.
Blood delivery system. Blood pump moves blood from access site through the dialyzer and back to the patient. Blood flow rate is 250 to 500 ml per minute. Procedure. Blood flow rate is 300 to 500 ml per minute. Dialysate 500 to 800 ml per minute. It is usually done 3 times a week and each dialysis lasts for 4 hours. Complication of hemodialysis: hypotension, cramps, nausea and vomiting, headache, chest pain, back pain, itching, fever and chills.
With this, we conclude our presentation. Thank you.
Thank you.